Okay, in the next few minutes, we will take a look at how to prove that something equals an empty set. And so take a minute here to read this first table to understand what the method is going to look like. Okay, so the idea behind proving that something equals the empty set is to basically do a proof by contradiction and suppose that the intersection is not empty and somehow derive a contradiction. I'm going to demonstrate that with example number 7. So this says prove that for any set A intersected the empty set is automatically the empty set. So this is going to be a proof by contradiction. So let me go ahead and set it up. So as we do with all the proofs by contradiction, I'm going to say suppose not and suppose that A is any set and A intersected with the empty set is not the empty set. Now hopefully this will lead me to a contradiction, and when it leads me to a contradiction, I'll know that this assumption over here is false, and so the original problem is going to be true. Now let's interpret what it means for A intersected the empty set not to be empty. So since A intersected with the empty set is not the empty set, that means there exists some x inside of A intersect the empty set. Okay, so it's not empty, so that means there's some element in there. But by definition of the word intersection, we can say that x is in A and that x is inside the empty set. Okay, so the intersection symbol, that's the same thing as the word and, basically. Okay, so they can be interchanged. And to say that x is in A and x is in the empty set, that's what it means to say that x is in the A intersection with the empty set. But this is nonsense, but this is completely false. How come it's false? It's false because it's claiming that x belongs inside the empty set. And how could this be true? It's not true. The empty set is by definition empty. So this is false because the empty set is empty. So we reached our contradiction. So this is a contradiction, and so therefore we are basically finished. The theorem is true.